why we need to understand about the functions? The reason is that in the introduction, academics and the managers are interested in examining various types of relationships. This is important thing. And one variable and another variable and one point and another point, how they are linked to each other, how it is related to the each other. Right? For example, here they have given. Look at the amount of money a person earns and the amount that the person chooses to spend. Right? Person earning amount chooses to. This is a consumption relationship or a function. See that? A relationship or a function. A function which is relating to the amount that I earn and the amount which I spent. Right? Now, another example. Look at the amount of money a business firm has and the amount it chooses to spend on the new equipment. I have a business. How much amount I am earning? Induja, can I am muting your mic. Sorry. Right. Um, yeah, business firm. How much it chooses to earn. I mean, chooses means how much I earn and how much I spent for the new equipments or the development, or in another words, for the growth of my uh, business. What can I do for that? Right. That important aspect, that important key thing that we are going to learn. That I mean, it's a function, right? This is an investment relationship or the investment function. See that? You need to understand. Function means why I learned, I am going to learn. We need to understand this, right? And this function tries to define these relationships. It tries to give the relationship a mathematical form of equation. Right. Let us say x and y if in the equation. All of you know that, right? In the equation x and y. Because I hope everyone studied 10th class, right? I'm just kidding. Everyone must study, then only other things definitely you will be eligible to study, definitely, right? And now here in the 10th class mathematics, you might be studied about f of x is equal to x square plus 2y or x square plus x, like that, right? And the function tries to define these relationship. It tries to give the relationship a mathematical form of equation, right? And it will tell different quantities. It will tell the different quantities. These quantities are represented as variables, constants, and the parameters. See this. You need to understand this because these are all the 10th class. Maybe you might study 2 years back, or I don't know when when you have studied that, but whatever, right? These quantities are represented as variables. Let us say, now I'm just telling, give an example. Um, can someone please respond immediately? Let us say, uh, the profit. Let us say I have a mouse. This is a wireless mouse. Are you able to see me? Are you all there?
Yes.
Yeah, this
Yes,
is
sir.
wireless mouse. Okay. If I sell a product mouse like this, I am getting, let us say, 10 rupees profit. Okay, 10 rupees profit. Now, 10 rupees profit. I'm getting 10 rupees profit. Now, if I sell 10 products, how much profit I will get?
100.
10
100.
into 10, right? 10 into 10. Now I'm making as an equation, not an complete equation. I'm just telling 10x, I said 10x is the profit which I earned by selling this mouse. Now x denotes the number of mouses. If I sell 100 mouses, 10 into 100. What is x denoting? The number of products which I sell, right? Now I have a mobile in my hand, mobile and what is this? Mouse. If I sell mobile, I am getting 20 rupees profit. I'm getting 20 rupees profit. Okay. I framed the equation like this is profit is 10 rupees. For this profit is 20 rupees. Now I said a equation like 10 into x plus 20 into y. X is mouse, Y is mobile. Now, let us say today I sold. Let us say who is there in the meeting now. Let us say Anjali is there. Anjali. Anjali is a sales girl. Anjali sold 12 products of mouse, 12 products, 12 mouses. And here someone who is there in the meeting. Shravana or Sharda is there. Okay. Sharda is there. Now Sharda and Shravana. Sharda is there. Sharda is the sales manager for the mobiles. And she sold, let us say, 20 mobiles, right? 20 mobiles, Sharda sold, and 10 mobiles, another girl sold. Now, what is the profit of both the products combined? Can someone tell?
520.
Simple, very simple. That is this is an equation. This is the relationship between the, this is the equation which is relating to my profit, right? Now, all the things I'm representing in an equation so that I can maintain a relationship with those two variables, what I'm taking here. Sometimes it may be a constant. Let us say, for constant means which won't change. See here, I use the word X. I use the word Y. Okay, let me change my hands. Yeah. I use the word X for, I mean, X representing mouse, Y representing mobile, and X profit is 10 rupees. I said for mobile, it is profit is 20. 10 into X plus 20 into mobile Y. Let us say mouse. Okay, both are starting with M only. That is a wireless mouse. I am denoting as a W, mobile as M. Profit on mouse is 10. Profit on selling mobile is 20. Now 10 into wireless mouse W plus 20 into mouse M. So this is an equation. Now I have, oh, let us say 200 people, sales people are there. Now for the mobiles, and 300 people, sales people are there for my mouse. What is the profit I earn? Simply you put it in this equation which we framed now, 10x plus 20y, then you will get what is the per day sales that you did or per day profit that you have earned in your shop. Are you understanding what I'm trying to say? Are you all there? Hello?
Yes.
Are you
Yes.
understanding the importance of the equation? This is how the equation frame. This is how the function frame. This is how the, what we call the variables and the constants. Now, 10 profit, when I sell the mouse, 10 is a constant. It won't change. But number of mouses, definitely it will change. Today the sales may be 20, tomorrow sales may be 30. That is why we are calling it as a variable, which will vary. Variable means a vary. Constant means it won't change, because I made this, I manufactured this mouse for some, let us say, 50 rupees. I am selling it for 60 rupees. Profit is 10 rupees. Today or tomorrow or day after tomorrow, the constant, it won't change. Right? That is called constant. Those are the variables. Parameters are the combinations of those things. Let us go into that. Now, definition, what is constant? The same with the quantity whose measure is the same with all the situations. If Shravan did the sales, or if someone, Shravana did the sales, or Sharda did the sale, or Shravan Kumar or Induja did the sales, whatever the sales, but this X, or the, I mean, mouse represent W, no, W may change, then it is called. Now, what is parameter? Parameter is a situation constant. If the value of a quantity that is constant in a particular situation, but which can vary from one situation to another, is called a parameter, right? So maybe in one situation it is the same. In another situation, if it is varying, then it is called as a parameter. But constant in all the situations, it is same, right? Generally, instead of x, y, z, we will represent the constants as a, b, c for a standard for the fixed number. Right. Now, see, parameters are closely related to the variables, and the difference is sometimes just a matter of perspective. Variables are viewed as changing, while parameters typically either don't change or more slowly. See, when you read your books, you will understand. Variable means which measures varies between a situation. From one situation to another situation, it will vary. Generally, this variable we represent as a variable price P. Q is used for the variable quantity, because sometimes price will vary, quantity will vary, like that. Now, see, what is a function? A relationship of all the above three: constant, parameter, and variable, right? Now here we can see that the letters of alphabet ABC, this is an equation, this is a function. f of x is equal to ax square plus bx plus c, and the variable x is regarded as the input to the function. Input means what I will say that input, let us say input will change. Now input I am putting today, I sold 10 mouses. X is equal to 10. Put x is equal to 10. A into 10 square plus b into 10 plus c. Now what is ABC are the parameters that determine the behavior of a function. For each value of the parameters, we get a different function. Now see, domain and range of function. This is also important thing to understand. Now, a function in a rule corresponding to the mapping xyz that assigns to each real number x, then input, to a certain set d on a real number y, the output x, y. When you put the input, the thing what is coming out is the output. The set d call as the domain of the function, and y is the dependent variable. Right. There are some dependent variables and independent variables. Now, generally, in an equation, in the domain, y is a dependent variable since its value depends on the value of x. Now, let us say dependent and independent. I will just tell you an example. Now, petrol prices are dependent on what? What variable? Based on the, right? Let us
Export function.
exports and the import. If the import values are increasing, definitely that prices will definitely. This is an independent, right? Petrol price is a dependent variable on that import prices, like that. Thank you for that example, right? Independent variable. See, this is what domain range. In the x and y, we will denote that. What are the types of functions? I will go fast. Constant function, right? Any non-empty sets will be there. And the algebraic function defined as called as an algebraic function. This is how this algebraic function will come. And constant function, it denotes with the small f. Monomial function 4x square, like these functions will be there. Polynomial function, right? There are two x and y will be there, and here x cube plus y square plus 2x square. See here, this is limited to the x square till square y square monomial, right? And here this is polynomial, more than two. Generally, they will call it as a two or more items, right? More monomals, if it is comes, then we call it as an call. Sometimes this polynomial is also binomial equation. Next one, univariate, where the single independent variable will be there. Multivariate, more than one independent variable will be there. And linear function. This is one of the important thing. This is called as a polynomial function with the degree I. And the most general form of linear equation is this quadratic function. F of x is equal to x square plus bx plus c. Cubic function. This is the thing where the degree will be 3. Identity function, right? A to B, and which is belongs to that. Relationship function. There will be, when there is a relationship between two function, then we call it as a relationship function. Trigonometric function, where if you use the trigonometric signs, sin x, cos x, tan x, like that. Maybe if you remember that your 10th class again, you will understand. Exponential means it is an exponent power. Exponent power, x square, it will be double the things, x square, x cube, like that. Algorithm function, right? And a function which variable appears in an argument of a algorithm, we call it as a log x. Maybe like, now what is the solution for a functions? See, this is very, very important. What is the solution for a function? Generally, we know that the variables x, generally in an equation, variable denotes the x denotes the variable, right? The value of x at which the given function f of x become equal to 0 are called at the solutions or roots or zeros of a function. If the f of x is equal to 0, equal to 0, for a linear function, f of x is equal to y is equal to ax plus b. We already see what is linear function about. The roots are given below. Ax plus b is equal to 0. Then x is equal to minus b by a. What is the solution for an function x value? Finding out the x value is the solution for a function all the time, many of the times, right? And when we substitute this in this equation in a linear function, its value should become 0. like ax squared plus x is equal to minus b by a. And when we divide, then this quadratic function y is equal to ax squared plus bx plus c, we have to solve the equation by. If when we want to solve the equation, we need to equate with 0 and find the roots of the y. Now, there are two values of x for which y becomes 0. One value is x is equal to this one. When you put x value, when you find out the x value and when you put there, then the y becomes 0. Very simple. In the simple words, when you're identifying the x value in a particular equation, that is the solution for that particular equation. Now, where we will use this? See, everything. Yesterday I was in a farewell. There is a professional dancer from my college, and I spoke with her, and she said like, I'm working for an organization where um, I'm applying this mathematics into the dance. Oh my God, how you are applying? I said, and she said like, sir, in the mathematics, the things which are coming, which are related. She used some technical words. I don't know much about the dance. She used that technical words and how this model, mathematical model, will help or will affect your dance movement. Some word she used. I don't know. That is why I forgot the word she used. I surprised to hear that. Why I got surprised means they are limiting the scope of the applicability of the mathematics to many. So there are something which you can't use in all the things, right? We can't use in all the things. Only it is applicable to some situation or few situations, right? Yes or no? And she is trying to apply the mathematics into the dance. Oh, see, then scope is increased. Now your mathematics we can use in the academics, mathematics we can use in the business. I'm just using the example mathematics, but here these functions are used in many areas where in the break-even analysis, in the academics, business, cost, total revenue, right? The number of units and the revenue needed to cover the total cost. At what point? What is break-even analysis? That point where our expenditure will meet at how many products. If I sold, let us say I'm producing some 1 lakh products, the break even point is, for your example I'm just telling, what is the break even point, how many products we need to produce in order to get our revenue back at that point, that we will understand here in this, right? That cost accounting refers to the point in which total cost and total revenues are equal. The cost. What is cost? The amount which I sold, like or the amount which I invested on the mobile to manufacture a product. Let us say this is 26,000 rupees mobile, and let us say the cost for the company, maybe you can say some 10,000 rupees, right? And 16,000, all the tax, all the stuff, they let us say, let us consider it as a profit. What is the break even point? When I sell all these products which I make for this, when I reached all, I produces some 100 mobiles, right? And I sold some 50 mobiles. If after selling 50 mobiles, I got the complete investment of the 100 mobiles amount, that point we call it as a break-even point. See, simply in technical words, they use total cost will is equal to the total revenue. When both are equal, then this we call it as a break-even. Where they will use the equation. See, f of FSV. What is F represent? The fixed cost divided by selling price and the variable cost per the unit. This is the equation for the weight per. So now let us say if you see the illustration, what is the break-even point should be brought down to 6 units. Calculate the selling price per unit if the break-even point should be brought down to 6,000 units. Given that the variable cost per unit is 15 rupees, selling price is 20 rupees, and the fixed expenses are 54,000. Right, my expenses for manufacturing the units is 54,000. Right, and how should I do this? See, very simple. Fixed expenses or the cost 5,000 this one, divided by selling price by variable cost, and 554,000 divided by 5, I got 10,800 units. See this? When you sell this 10,800 units, then only you will get this 54,000 back. This point we call it as a uh, break even point. To know the break even point, the question is that how can I bring to 6,000 units? What should I do? Again, 6,000 is equal to break even point is equal to fixed expenses. I know. Now selling price I need to notice. Now 6,000 is equal to 54,000 by selling price minus 5. Selling price is 24 rupees. If I put selling price as 24 rupees, then I can get, right, the break even point to 6,000 units. See, this is what is this? These are all the equations which I used, and the cost function is another cost function is what? It is equal to variable cost per unit, number of units manufactured, fixed daily or overhaul, cost per unit, number of units sold, and total revenue minus total cost. Simple profit. Right? Illustration. If you see this, you'll understand this. Very easy. Demand function to understand the demand. Now, there is an equation for that. Right. Now, let's go into the sequences and the series. What is sequences and what are the series? Now, word sequence denotes certain objects or events occurring in the same order. In one order, it is happening. A set of numbers arranged in a specific manner. Right. The applications of sequences can be found in many areas, including the process of analyzing academic data or the physics. Sequences are important in developing mathematical topics which themselves have wide technical application. In other words, those are right in a proper order. I said, let us say 1, 3, 5, 7, 9, 11. What are these order?
Those are the odd numbers.
Odd numbers I'm using. So I am writing the numbers in an order. 1, 2, 3, 4, 5. There is a series. There is a gap of 1 between one, right? And we can understand that. When we understand that, let us say uh, there is a queue. There is a queue. If I know the sequence of the queue, you will understand who will be the next. Let us say I'm keeping based on the alphabetical order, a sequence order, alphabetical order. That is, my name is Roy, someone name is Anjali, someone name is Bharat, someone name is Chandra, right? Anjali, Bharat, Chandra are in the line. That who will be the next? Whose name starts with C? Whose name is, because a series sequence is following, alphabetical sequence is following, right? Based on that sequence, we will understand that who will be the last person, who will be the next person, right? And series and also we will understand. See that number of sequence position is one, and a member sequence is 1, 4, 7, 10, and nth number. Now, for examples of the sequence 1, 4, 9, what sequence is there? 1, 4, 9. 4 minus 1, 3. 4 minus 1, 3, 5. Next, what will the gap? 7, 9. Like some odd number gap is coming. 1, 3, 5, 7, 9. We know that all odd numbers. Next, 1, 2, 4. There is the same difference is there. 1, 3, 7, 15, 31. There is some difference. So you can understand that, right? Where 3 and 4 are the infinite. This is the finite, various 1, 2 are the finite because last number is given finite. It is limited to 1 to 20, 121. This is limited to 1 to 21. Here infinite series, it will go on, go on, go on because dots are there, right? Now, based on this, let us go into the AP, arithmetic progression. Right. It is a sequence in which each term after the first word is obtained by adding a fixed number to the preceding term, which we call is as an arithmetic difference. Same, if I write three numbers, I can tell the fourth number because there is a sequence that we are following. We call it as an arithmetic sequence or arithmetic progression. What is the definition of arithmetic sequence? A fixed number to the preceding term, or the common difference is coming. 1, 3, 5. Oh, no, no, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Common difference is 1, right? Based on that, what will be my 100th number? Of course, 100 only. Because the series is from the first two. By understanding the sequence of few numbers, you will understand the sequence of the other things, right? Now, the quantities are said to be in arithmetic sequence when they increase or decrease by a common difference. That thus each of the following series forms an arithmetic progression. See that 3, 7, 11 common difference. 8, 2. I think 8 minus 2 minus 6, 2. 2 minus 6 minus 4. Minus 4 minus 6 minus 10. See, some minus 6 is the difference, the common difference. What are the characteristics? If a constant quantity is added to a subtracted from each term of an arithmetic progression, that the resulting terms of the sequence also in AP. That is a 2, 4, 6, 8, 10. Right. That is the series. Let us say if I subtract 1 from all the values, the same will come. Right. 2, 4, 6, 8. If I subtract 1, 2 minus 1, 1, right? And 4 minus 1, 3. Some series will come. The same difference will be there. That is the property number 1. Property number 2. Thus, it is multiplied or divided by a non-zero, non-zero constant quantity. Then the resulting sequence form an arithmetic progress. And next, let us see the third progression. It is a finite number of terms. The sum of any two terms equidistant from the beginning and end is equal to the sum of the first and the last. This is the thing. Now, property number 4. There are three values are there. If only if 2y is equal to x plus z. This is also another property. Now, by understanding this, you can apply anything. Let us say 1, 2, 3 is there. 1, 2, 3. What is 2 here in XYZ example? Y is equal to 2, X is equal to 1, Z is equal to 2. Put this value in this. 2 into Y means 2, right? 2 into 2 is equal to 4. X plus Z is equal to 1 plus 3. 4. 4 is equal to 4. Someone defined this, or someone came with these equations. When we use it, this is the thing. These are the problems. You can see that an is equal to an plus b. If the terms are selected as a regular interval, also the arithmetic progression will be the same. The nth a term of an arithmetic progression also we can understand by using this. Let us see this. What is the seventh term of an AFP in which the first term is 11 and the common difference is 4? Say, if we use this, the seventh term will be designed as A1 plus n minus 1 into D. See this? Nth term of the progression. Already we defined this. Nth term. How I will get? If I know at least the common difference, if I know at least the one value 11, I can apply this formula immediately. An is equal to A1 plus n minus 1 into D. Right? N minus 1 into D. Because the D is, which word it is? A, B, C, D. Fourth word. Whatever the word you will keep, you will get it. Let us say on the seventh term, n is equal to 7, a1 is equal to 11, which is given, right? Difference is 4. A1 means in the arithmetic progression, first word is 11, it is given in that, and the common difference is 4. Definitely after the first term is 11, and what will be the second term? When the common difference is 4, 11 plus 4, right? 15. And 11 plus 4, 15, right? And 15 plus 4, 19. 19 plus 4, 23. 23 plus 4, 27. 27 plus 4, 31. 31 plus 4, 35. Which one is the seventh term? Are you all there? Are you understanding?
39.
35. Here it is given 35.
Yes.
31 plus 4, 39. If I keep on calculating 4 plus 4, 4 into that 4 plus 4 plus, oh, if because they ask the seventh term, We could add that 11, first term is 11. Generally in arithmetic, all the values difference is same. I know that 11 plus 4 is equal to 15, 15 plus 4, 19, 19 plus 4, 13, 13 plus 4, 17, 17 plus 4, 11, 21. All this. You count for the till 7. But if someone asks what is the 100th term, you can't do this calculation. We have a formula to find out any term. If I know the first value and the difference amount, I can get, see, first value A1 denotes the first value is 11 and n minus 1. We are asking the seventh term is 7 minus 1, 1 into the difference. Put that value, you will get 35. Manually, if I calculated, I got 35. And even if I calculated generally also, I got 35. Right? Even this illustration 2 also gets. Now, arithmetic series. What is this sequence? The sum of an indicated number of terms. Yes, who is this? Induja? Okay. Induja, you're talking something?
No, sir.
Okay, I think your mic is on and some words came. Right.
Okay, I can.
Now see, arithmetic series. A sum of an indicated number of terms in a series sequence is called a series. The series obtained by adding the terms of an arithmetical progression. This is called arithmetical series. Terms. If the number of terms in a series is finite, means limited number, then the series is called a finite series. While the series consisting of an unlimited number, it is called as an infinite series. The sum of first n terms of an arithmetic series is all the things a1 plus a2 plus a3 plus n, all sum of 1 to 10 items. See this? Then a1 plus a2 plus a3 plus till a10 will come. If whatever the sum of the terms of n items is, this is the for series. You put the value in that, find the sum of the series 51 plus 50 plus 49 plus 21. I don't know how many values are there. What is a1 value? 51. What is the difference? 50 minus 51 minus 1. What is a n value? That means last value is 21. Put this one, you will get some 31. Now using we have 31 by 2 plus 51 plus 21 is equal to 311. Now what is arithmetic mean? We understood what is arithmetic means. What is this arithmetic progression? In other words, arithmetic progression. Second one, we are understanding about the arithmetic series. Now, based on these two, now AM, arithmetic mean. Arithmetic mean of any two numbers A and B is given by A plus B by 2. Because why? The average of any two numbers A plus B by 2. What is the average of 1, comma 2, comma 3, comma 4 series? 1 plus 2 by 2. Then 3 by 2 is equal to 1.5. That is the average of two numbers. Average of two numbers 1 and 2 is 1.5. Right? You can do that. Now insertion of AM in the AP, arithmetic progression. If three numbers A and B are in AP means if it is in arithmetic progression, that means what? What is one property of arithmetic progression? Difference will be, hello, are you all following me? Arithmetic series, what is the characteristics of arithmetic series? The difference between any two values is same, right? Hello, are you all there?
Yes.
Okay. Now, if three numbers ABs are an AP, that means what? The difference between A and B and C are same. Then B is the arithmetic mean of A and C. Therefore, B is equal to A plus C by 2. Right? A, B, C, 1, 2, 3. What is the AP? Arithmetic progression of 1, 2, 3 means 2 is equal to 1 plus 3 by 2. 1 plus 3, 4 by 2 is equal to 2. 2 is equal to 2. You will get it. For instance, man of 2, 10 and 14 is given by how? 10 plus 14 by 2, 12. Right? What is 12 here? 10, 12, 14, second value. Right? This is how you can. What is GP? Geometric progression. Now, geometric sequence is second type of sequence. One application of geometric is computing interest on savings accounts. Right. Other application in the biology and physics, geometry sequence also has an application for finding the national income or population for any particular future year provided with the values. What is exponential or sequence or progression? Is a sequence of numbers in which each term after the first is obtained by multiplying the preceding term by a fixed number. Again, I'm repeating. Sequence of numbers in which each term after the first is obtained by multiplying the preceding term by a fixed number. Now let us see. 2, 6, 18. And which number is multiplied with 2 to get the next value? R. Right? 2 into 3 is equal to 18. 2 into, sorry, 6 into 3 is equal to 18. 18 into 3 is equal to 54. Right? R is equal to 3. Geometric sequence or the progression we need to understand. Is this a kind of a ratio? The common ratio will be there between 1 to 2. What is this common ratio in this? 2 by 1, like that, etc., etc., will be there. Now, characteristics property 1. For all the terms of GP is multiplied and divided by same non-zero constant, then the sequence remains in GP with the same common ratio. Right? You just secant that. These are the examples. Geometric sequence. Find the fifth term. Again, here formula will change. How I will get the formula? Can someone tell nth term in finding out arithmetic progression? What is the formula? Yes. What is the formula for getting nth term? They're not listening. See this again. Arithmetic mean nth term. Yeah. A plus and a1 plus n minus 1 into d. You can, based on that, we can get the arithmetic series. Understood. Geometric mean. How we will calculate the G series, G sets? We can see here. That's it. Right. Let's go into the geometric mean. In this geometric mean, insertion of geometry, how we will get it? If two numbers are there, I'm telling that both are in the geometric mean. Ratio is same. Then root of AB, mean is root of AB. When the geometric mean is placed between the numbers, then the resulting numbers will be also will be GP, right? A is equal to root of BC. Okay, these are the things we have in this. Now let's go to the another unit today, matrix algebra and applications. What is this? What we are going to understand here is the matrix, understanding of the basic concepts of the matrix, and represent large quantities of data in a matrix form, various types of matrices, their operations, compute and apply response, determinants and the investments of this. So what is the structure here? We're going to learn how we can represent a data in the matrix form. What is matrix algebra? Scalar multiplication of the matrix, response of matrix, and this. We will see that matrix again. We are going back to 10th class. Ninth, 10th. Very, very important topic in the 10th as per my knowledge. Long back I did. Anyone remember this about the matrix? See this? When it came, the matrix was introduced in the 19th century. Wow. And algebraic, this sub of systems. aspects of matrices in two papers in 1955. Oh, his head is that time only from 80s only he's from. Cayley recognized certain sets of matrices, an algebraic system in which many of the ordinary laws of arithmetic, right, are now not void. Now, see, what is a matrix? Matrix is a rectangular or a square array of numbers or other than data, such as strings of text arranged in rows and columns. You have seen that, right? Rows, columns, matrix. Now, let's go into this part. This is the structure of the thing. Example for the matrix is this. These are the numbers. Now, matrix equality. How I can say that both the matrices are equal? First one, the same number of rows should be there. Same number of columns should be there. Corresponding elements with each matrix are equal. For instance, these are the two matrices: triple one x, y, triple four. Triple one, A and B are equal. A and B are equal. Someone said, or some equation said. Then what is the value of x? Directly triple two. What is the value of y? Directly triple three. Now, yeah, this is the equality we found. Now, special matrices. There is a row matrix and column matrix. This is the row. Row means horizontal. Column means vertical lines. Right. Now, mm, digital diagonal matrices. What is the diagonal for these matrices? 0, 6, 0. This is the diagonal. I think diagonal won't come here with the mouse. 0, 6, 0. Right. What is the diagonal in this one? Can someone said 0 and 0. What is the diagonal in that? 0, 6, 0. What? Now, scalar matrix. What is scalar matrix? Right, it is equal valued elements along with the diagonal. Two examples of scalar matrices are this one. Three square matrices can play a prominent role in the application of matrix algebra to real world. For example, scalar matrix called the identity matrix is critical to the solution of simultaneous linear equations. Say that. Now, unit matrix. The unit matrix and the identity matrix is an nx n diagonal matrix. Where the I is the diagonal and zeros elsewhere else. And the matrix is I or IN. Right? These are the things. Now, null matrix. What is null matrix? Null matrix is a special, basically a matrix whose all elements are zero. If in the matrix, if all the zeros are there, we call it as a null matrix. How do data representation? This is what the distance, kilometers they have given, and the cities can be represented in the matrix. Cities I am representing ignoring ABCD cities or ABCD first row, second row, third row. Assignment matrix. There are three jobs by three works and can be represented in this matrix. Transportation matrix also. This is one of the thing. Assignment matrix, transportation matrix. You will see in your OR. Maybe you may not. Maybe if you go for PG and this, they'll talk about it. Now, brand switching matrix like this. Diet matrix. Two types of foods are there. Intake F1 and F2. If you take F1, protein is 750. So A of matrix is this, right? Matrix algebra. Now, for instance, consider matrix M are given. Both matrices are the same number of rows and columns, so that can be added and subtracted. Rama, listen to this carefully. When the matrix having same number of rows and columns, for these two matrices we have two rows and three columns. Here also three columns and two rows, whatever, but both are matching. Square is matching, right? We know that if I do A plus B, I can add 1 plus 5, 2 plus 6, 3 plus 7, like that. Right. And let's calculate the sum and difference of 3 by 3. Sum, adding, difference means taking. Simple. Properties matrix, commutative matrix. Example is this: associative party, addict inverse is party. Yes. Now there are few workings are there. Matrix A and B cannot be added because B has more columns than A. See that? A has only one column, A has two columns. Now see, A plus B. Can I combine A plus B here? How many rows are there here? Hello? Two rows. How many columns are there in A matrix?
One
One
column.
column.
One column. Can I add A and B here? One
No,
column
you
plus
cannot.
two columns? I cannot add. Right? A plus B is equal to C. Is it correct or false? First plus. B
False.
plus C is equal to D. See, B has four values. C also having four values. B plus C is equal to D. I don't think D because B plus C will be less only. See, 3 plus 4, 9 is coming. If it is D, 9 should be here. That means it is a false. B minus C is equal to D. We'll check. 3 minus 4 is equal to minus 1. What? That is
Minus
correct.
1.
5 minus 5 is 0. 6 minus 4 minus 6 minus 2. 6 minus 6 0. Oh, this is correct. Only 3 is correct. We understood that number of rows and number of columns, if they are equal, then this can be done. Then working. So it's very easy. Adding and subtracting with the matrices are very, very easy. I'm not getting into that. Now secular multiplication, let's determine 5a. 5 into a, you multiply this, it will come, right? Other